If I have another function where its discrete graph is in a circle form, look, all the points are separated from each other. They are not continuous. There is discontinuity in this graph. It is called a discrete graph or a digital graph. So I'm going to find the domain and range from here. This point is located on 0 along x-axis and 6 along y-axis. Here it is situated on 4.5 along x-axis and 4 along y-axis. At this stage the graph is 6 along x-axis and 0 along y-axis. Here it is on 4.5 along x-axis and -4 along y-axis. Here I have 0 along x-axis and -6 along y-axis. At this point I have -4.5 along x-axis and -4 along y-axis. At this stage I have -6 along x-axis and 0 along y-axis. At this point I have -4.5 along x-axis and 4 along y-axis. These are the coordinate points along x-axis and y-axis of this discrete graph. So I'm going to find the domain and range from here. Its domain will be -6, -4.5, 0, 4.5, 6. All the x values or all the x coordinates show the domain for this function. But there are some values along x-axis. They are repeated on both sides. So I'm going to take a common one. I will take it once, not twice. If you look at here, these both points are located on -4.5 along x-axis. They are located on a single point. So I'm going to take a -4.5 common. I will take it only once. Similarly here, these 2 points are located on a single place, which is 4.5 on x-axis. So I will take 4.5 common. I just took 4.5 once. Same thing goes for the 0. I have 0 at 2 places along x-axis. So I will take it only once. For the domain, I took -4.5 common, 0 common, 4.5 common. -6 and 6 are not common. Range are all the y values, which is -6, -4, 0, 4, 6. These are the coordinate values along y-axis. I have -6 from here and then 6 from here. Same situation is here for the range. There are some values that are repeated on both sides, so I'm going to take the common one. If you look at here, I have y equals to 4 on both sides, which means that both the points are located on a single place. They join a single place, which is 4 along y-axis. I took 4 only once from here. Similarly here, look at here, -4 is repeated on both sides. Both the points join a single place along y-axis, which is -4. So I took -4 common from here. And same thing goes for this. I have 0 common along y-axis at this stage. Both the points are located on 0 along y-axis. Y value is 0 here. Therefore I took 0 common. For the range, I also took 3 common values of y, -4, 0, and 4. These are my domain and range from this discrete graph. Let's suppose I want to make it continuous. I'm going to join all the points here. If I join all the points to make a complete circle, if I want to join all the points, I got a pure circle, a continuous circle. Now the graph is a continuous graph. It's no more discrete or digital. It's a continuous graph. I have a circle right now. To determine the domain and range from now, I'm going to follow the normal and the usual method. Its domain will be -6 and +6. X equal to and greater than -6, equal to and less than +6. Because this circle joined the border on -6 along x-axis and +6 along x-axis. So -6 and +6 is my domain. These are the x values of the x coordinate points of this circle. I have equality sign on both sides. Because of the vertex, remember there was one example last time that I did, that if I cut the circle in half along y-axis, I'm gonna get rightward parabola on the left side and leftward parabola on the right side. So it makes a kind of vertex here on -6. So because of this vertex, I have equality sign. And because of this vertex, I have equality sign for the other side. Or to write in ordered pair, I have close bracket on both sides with the -6 and 6 because of the vertex. Now let me find the range. Its range is -6 and +6. Y equal to and greater than -6, equal to and less than +6. Because this circle joined the y-axis at this point on -6. And the other stage is here. which cut the y-axis and positive 6. So this negative 6 and positive 6 are the only points where this graph or this circle cuts the y-axis. So negative 6 and positive 6 is my range. But again, there is equality sign for both sides. Equal to and greater than, equal to and less than, which means that including negative 6 and including positive 6. Same situation is here. If I cut the circle in half along y-axis, I'm gonna get downward parabola for the upper side. One is the rightward parabola from downward. So it makes a kind of vertex at 6, and the second parabola makes a vertex along y-axis. So because of this vertex, I have equality sign for both sides. Or to write the range in ordered pair, negative 6, 6, inside closed brackets on both sides because of the vertex. Again, I repeat it here. If the question asks that find the domain and range from discrete graph, you only do the discrete part. You don't need to do the continuous part. It is just for common understanding that I did for you, that if I make it continuous, its domain and range method is different compared to the discrete. That's what I mean. If I have one more function where my graph is a discrete graph, like here, it's a line, but in points they are disconnected from each other. That's why it is called discrete graph or digital graph. At this stage, the point is on 3 along x-axis and 7 along y-axis. Here it is on 0 along x-axis and 3 along y-axis. At this stage, it is on negative 3 along x-axis and 0 along y-axis. At this point, it is on negative 5 along x-axis and negative 3 along y-axis. To find the domain, I'm gonna write all the x values or all the x coordinate points. This is my domain, negative 5, negative 3, 0, 3. There is no value which is repeated. Therefore, I'm gonna write all the x coordinate values for the domain, negative 5, negative 3, 0, and 3. I put all the yellow values, which are the coordinate points along x-axis for the domain. Similarly, its range will be negative 3, 0, 3, 7. I put all the y values for the range. There is not a single value which is repeated for the y. So I put all the y values for the range, negative 3, 0, 3, and 7. Again, let me make it continuous. I joined all the points with each other to make a continuous graph. The graph is continuous, there is no discontinuity. The domain from this continuous graph will be the x values at this point and the x values at this point, which is 3 and negative 5. It's a continuous graph. I have nothing to do with the points in the middle because it is no more discrete. It is a straight line. It is a continuous line with the two ends. So both the ends have filled in circles. One is on 3 and the other is on negative 5 along x-axis. So negative 5 and 3 is my domain. X equal to and greater than negative 5 equal to and less than 3. Because both the ends, whether it is here or whether it is here, they have closed bracket. Therefore, I have equality sign for negative 5 and equality sign for 3. I have no more of these points. I'm only considering this point and this point. Its ordered pair will be negative 5, 3. There is a closed bracket with the negative 5 because of the filled-in circle, and a closed bracket with a 3 because of the filled-in circle. Its range will be negative 3 and 7. Y equal to and greater than negative 3 equal to and less than 7. There is a filled-in circle on both sides. So I have equality symbols on both sides. Its ordered pair will be negative 3, 7. There is closed bracket on both sides because of the two filled-in circles. There was the continuous part. So it is a clear difference. If you look to the domain from the discrete graph and domain from the continuous graph, they are exactly one thing, but its method is a bit different. Because look at here. Continuous say that the domain is between negative 5 and 3, including 3 and negative 5. The same thing is here. Its domain is between negative 5 and positive 3, including negative 5 and positive 3. Its border is negative 5 and positive 3. And the same thing goes for the continuous. This is the border negative 5 and 3. These are the border values, but including negative 5 and 3. So these are exactly one thing. Its method is a bit different, and there is no more difference. There is no more difference. Same thing goes for the range. These are the border values negative 3 and 7. So range is between -3 and +7, including -3 and +7. Same thing is here for the range. In the discrete graph, these are the border values -3 and +7, because 0 and 3 come between -3 and +7. So it's exactly same thing. There's not a big difference.